Hello, I'm Yaron, a CTO of Equazio, which is now part of McKinsey. Today we're going to speak about how to build and deploy generative AI applications in the enterprise. So generative AI is the buzz today. Technologies like ChatGPT in 5 days reach 1 million users. That's faster adoption than any other technology industry. Everyone is talking about, everyone is trying to deploy it and implement some real business applications out of it. The challenge is that today it's very expensive to train your own model. Some companies invested tens of millions of dollars in building the model. You don't really want to train your own model. There's lots of risk associated with this technology. So intellectual property constraints, privacy issues, reliability issues. Those bots don't generate the right response all the time. Regulatory compliance risks and so on. And it's very complicated. There's a very complex stack around it, GPUs and CPUs and new software frameworks and distributed computing and new ideas and how to process all that data and train and so on. So it's really hard to do that. So before you dive into those challenges, let's see how is the right way to do it right. So first, leverage pre-trained large language model. Don't invent your own. It's very expensive, very complicated, lots of data to train. Personalize it to your own need using your own proprietary data. So you want to train it on a specific application, bring specific data, and enhance the model with that data. Third, you need to address those risks that we talked about. How do you do that? You invest in data quality and preparing the data before the training. You invest in lots of testing to verify that the model is doing just what it's supposed to and nothing else. And you put some guardrails, so whenever it's answered the answer, you have to verify that this answer is correct, it's not risky, it's not toxic, and so on. And you need to add human feedback, so someone actually examine what's going on and taking that feedback and feeding it and retuning your model. You want to build all of that is in a scalable, automated, and continuous development environment where you can keep on doing all those tests and redeployments and retuning and retraining in a very easy way without tons of labor. And you want to keep your design flexible. Why? Because this technology is still relatively new. There are new technologies, new libraries, frameworks being introduced on a weekly basis. So what happens if you bet on the wrong horse? Keep things open so you can build new solutions and adopt to the market. So how do we do that? Essentially, there are two pipelines that we need to build. One is to build and tune the model. The other one is to use the model. So the first one is essentially taking data, your own data, potentially data collected from a feedback from humans and from machines, preparing it, cleaning it, making sure that it's going to generate the best result. It doesn't contain proprietary data and so on. Do this tuning of essentially taking the base foundation model, doing transfer learning, adding some layers into it that understand your specific data and generating the tuned model. Once you've done that, you have to do some evaluation to see that it's actually doing the right thing. You do a lot of testing to verify that it's not misbehaving. And finally, you need to automatically deploy that version into production using automated deployment. So that's the batch pipeline of building and deploying the model. What are we really deploying is an application. This is the second pipeline. The application essentially takes a request coming from an API, from a bot, and so on, contextualizing it with some state, the information potentially from the previous question, maybe vectors, maybe some documents you want to examine, and so on. Doing prompt engineering, which is essentially tuning the question to the model so it will behave exactly the way we want it to behave. We feed it into the foundation model, which spits out the result. The result is not always the final product. We need to format it, we need to clean it, we need to verify that it doesn't contain toxic material, intellectual property, and other risks and violation. And we respond to the user. In the same time, we monitor all the results in a monitoring system. So later on, we can examine the behavior, we can label those results, and put a feedback loop, as we mentioned before. And this is how you build this production pipeline. The training to build essentially the tuned model and the application. We're going to see how we're going to use MLRun, which is an open source framework. You can see mlrun.org for more details. All the source code for the demo sits in this URL in GitHub. So you can just go into the demo, the source code, the notebooks, and so on. And this demo is essentially what it's doing. We're taking a model-based model, teaching it about MLOps, and then we're going to ask questions about MLOps. Without further ado, let's move to the demo.
Hi, I'm Guy Lecker, a machine learning engineer at Equazio. and I'm going to show you how we fine-tune a large language model on specific data, our MLOps blogs from iguazio.com. We'll be using MLRun, our open source MLOps orchestration frameworks. So let's begin by testing a large language model. We will take a model and ask him what is MLRun and what is machine learning. As we can see, it is trying its best, but it's not near perfect. So we want to fine-tune it. In order to do so, we will build a training pipeline. We will use functions from the MLRun Functions Hub to collect the data and pre-process the data. And because MLRun is fully integrated with all the machine learning frameworks, we will use Hugging Face and Deep Speed, and MLRun will take care of the GPU allocation, the training distribution, and so on. So let's run our training workflow. Here we can see it's ran, we see all the results, and we can see the training distribution. MLRun automatically scaled up 16 workers and allocated the GPUs. GPUs are only allocated for the duration of the training to keep the cost as low as possible. In addition, we can see here the MLRun UI, where we can see all of our functions as the pipeline steps with artifacts, results, and so on. Now, when we have our model, we want to build an application with it. So we will use MLRun serving graph technology to build a fully automated and scalable serving graph with pre-processing, post-processing, and so on. With just few lines of code, we build the graph as shown above, and now we can test our model. So let's ask him again, what is MLRun? And now we can see MLRun is an open source MLOps orchestration frameworks. And what is machine learning? Machine learning is the process of applying machine learning algorithms to data to create new models. Not perfect, but a significant improvement. Now let's add the GUI to our application using gradio, and voila, we have our application where we can submit a question and get an answer. Thanks, and back to you, Yaron.
So we've seen in the demo 4 things. One is how do we automate the flow of tuning, validating, and so on, building and deploying the model automatically without too much code, just a few API calls and that's it. Second, we've seen how we can rapidly deploy scalable real-time pipeline with multiple stages of the pre-processing and post-processing and scoring and toxic language detection and so on. All of those things, those 2 things are running on elastic resources, dynamically allocating CPUs and GPUs. You don't waste too much money if you don't really do anything. It all has built-in monitoring, so you can see some of it, we've seen some of it we haven't seen for the models, for the resources, for the training artifacts. Everything is being monitored and tracked automatically without a single line of code. And last but not least, this is all open technology. It's open source. Could be deployed anywhere, on cloud, on premises, wherever you want. It's an open ecosystem, works with any framework, with any large language model, so you're not confined into one solution. So with that, we hope to see you and approach us if you need any help. So there are 3 contacts here in McKinsey that you can address. One is Alex, the global lead for Quantum Black, Saf, CEO and co-founder of Iguazio, and myself, Yaron, CTO and co-founder of Iguazio, which is now part of McKinsey. Thank you very much for listening, and call us if you need any more help.